All right. Well, thanks for coming. I'm going to talk about some of the challenges we have to face when it comes to being a polyglot programmer. I'm a huge fan of programming languages. I program in about 15 different languages. And I truly believe that we need to be able to use the sharpest tools that are available. But of course, the mainstream languages evolve at a very different pace. And there are some challenges to using mainstream languages compared to using some of the other languages that are available to us. On the other hand, of course, not everything is green. There are some problems we'll run into if we don't follow certain discipline. So that's what I want to focus on today. So I'm going to say it's going to be, it could be heaven, but it could also be hell when it comes to using multiple different languages. So being a polyglot programmer really requires continuously learning, continuously adapting to various different languages and changes out there. But when it comes to developers, what makes us more productive? And I'm going to say, first of all, we are what we eat. And it depends on what we eat and how healthy we are matters based on what we eat. Of course, other factors are part of what influence that as well. But then, of course, when it comes to eating, there are different organizations that seem to be selling different things. For example, I ran across this one, which is kind of scary. And, what does that even mean? So the point really is we have to be careful what we eat. But in this case, what I mean by eating is not eating food. What I'm talking about is what do we put in our head, in our minds. And that's what I want to really focus on in this case, is what influence us is what we think, and what we think influences really is based on what kind of input we get into our minds. So it's the knowledge that I'm talking about rather than the food in terms of eating in this case. So the question I want to ask is, what do you read? What kind of books do you read? What kind of articles do you read? What kind of code do you read? That is something we need to really think about quite often in terms of how effective we're going to be as developers. And that also brings the question, what language do you predominantly use? And it turns out, if you look at the corporate world, we got several millions of programmers out there. And a vast majority of them go to work and use one language throughout the day. And they spend years programming in just one language. The good news about this is they get really good at that one language, but the bad news is that they are not really as familiar with a lot of other languages that are out there. I would say that was exactly me about 30 years ago. And I went to work, and all I did was program in one language, and I was so happy programming in that one language, and I completely eliminated everything outside of that little bubble. And then one day I woke up to realize that while I know so much about what I do, I knew very little about things that were outside of my scope. And that really scared me and made me realize that I need to diversify my knowledge portfolio and start learning different things. And that's been absolutely an eye-opening experience for me. So it's a question of what language do you use, but more important, I want to ask the question really is the fact of asking. Let me switch over here. So to ask the question, not what language do you use alone, but also to ask the question, how many languages do you actually use? And there are developers who use one language. There are developers who use 2, maybe 3, maybe 4. And how many languages you use makes a very huge difference. And this brings us to one reason I really want to emphasize that we need to be using multiple different languages. Now, just for a minute, take people in this room. Being here in Poland, I can say that everybody in this room, I can attest, speaks at least 2 natural languages. You probably speak your own mother tongue, and maybe you speak English. Unless you are only a native English speaker, then unless you have learned another language, you probably speak only English. But this particular hypothesis I came across was very intriguing for me, because this hypothesis says that the language molds our thought. And the Safarway hypothesis says that what we think is influenced by the languages we speak as a human being, the natural languages. Now, this was intriguing because I always thought that we speak in words what we think. But these guys are saying quite the opposite. They are saying what we think actually is influenced by the languages we speak. And they're saying that if you predominantly speak one language, then your thought process is fairly limited compared to when you speak multiple different languages. Now, I'm not a natural language expert at all, but I'm a huge fan of programming languages, and I can definitely attest this to you about programming languages. If you program in multiple different languages, it fundamentally changes the way you design your code for the language you program in. And I remember this one experience very clearly. I was working on a project in C#, and a very nice developer, I was pairing with this programmer, and he wanted to implement a particular idea in C#. And I asked him, do you want to enter in a thought? Do you want to implement it in a certain way that I can think of? And he said, yeah, why don't we give it a try? So we wrote a test, and then we wrote a code in a very different way than we would normally write it in C#. And the minute the code works, literally this programmer stood up in his seat, and he said, I've never seen a piece of code in C# like this. And when he was saying this, the team leader was walking by. He came and took a look at the code very quickly, and then he gave a pat on my back and said, are you trying to write Ruby code in C# here? And I kind of smiled at him and said, what do you think? And he's like, oh, this is pretty awesome the way it looks. And that is one of the things that excites me about learning different programming languages, is not that I want to go back and program in those languages, but I want to be able to come back and program in the language I program in, but very differently for the better. So if I know multiple different programming languages, then I end up using very different design thoughts and design tools when it comes to the languages that I'm programming in. In a similar way, I wrote probably the very first book on Java 8 when Java 8 was released, but I was very thirsty for learning how Java's Lambda expressions can be applied in terms of coding Java applications. But having seen Lambda expressions in multiple different languages before, in Scala and Groovy and Python and Ruby and so many other languages, I decided that I can apply some of those ideas into showing how Lambdas can be applied to Java. And that is really very heartwarming, because you're able to take a new feature in a language, but you're able to apply established ideas from other languages to come up with a better design of these ideas. So the surface hypothesis not only applies, I think, to natural languages, but I can vouch for it. It definitely applies to programming languages, absolutely. So in that regard, our thoughts are greatly influenced by the languages we use. And obviously here I'm talking about the programming languages that we use. Our thoughts are greatly influenced by the programming languages we use. And this is one of the reasons I often encourage programmers to really diversify their knowledge portfolio and learn multiple different programming languages. And when I say multiple different programming languages, what I mean by that is, if you know Java already, learning C# doesn't count. It's got to be a completely different language. And how do you know this language is completely different? It should make you really cry when you're learning it. It should make you feel the burden of learning it, and it should really change the thought process, and that's when you know you're really learning it, and that is absolutely important. And that is one of the reasons to really pick up different languages that are going to change our thought process, and we can learn and benefit from that. So in that regard, if you use multiple languages, you think and perceive very differently than if you know only one predominant language in that regard. And of course, the design of your software is greatly influenced by the languages you know as well. And if you were predominantly using one language and you design the software with it, and the minute you start learning 2 or 3 very different programming languages, then you end up actually designing the same software very differently, hopefully for the better, because of the influence of those languages and the thought process that kicks in. Even though your language may not support the structure or the construct very directly, you will find a way to bring in those influence into your design quite naturally. And I'm going to say that learning another different language changes the way that you code in your own primary language. And that is one of the biggest reasons why I really want to learn different languages. In a way, if you really think about it, it is like traveling. I like traveling around the world, not because I want to live in all those places, because I can't. But when I come back enriched, because I've learned a different way of doing things, a different way of learning. And sometimes I even learn a different type of food, and I threaten my family with my cooking when I get back and say, look, I can cook this for you. And absolutely, we can come back more enriched by these travels, and that's exactly what we do by these languages as well. And of course, if you know and use only one language or one type of language predominantly, like for example, a static type language, for instance, then you are at a very significant disadvantage when it comes to your ability to design software, and that is a limitation we definitely don't want to fall into the trap of. Well, in that regard, I look at some languages as black swan. Well, the idea of black swan was present in this beautiful book by Taleb, and he talks about events in our lives and technology in our life that are black swans. And an idea of black swan is that it is something that humans never expected, never anticipated, and the very first time they saw it, they were absolutely in a state of shock. Well, there are several black swans in our lives. There are some good black swans, like for example, Google, for example, when we started having the search engine and how it predominated everything, and the maps and everything. And there are some very bad black swans as well. For example, the current politics in the US is a great example of that as well. But leaving that aside, black swans are very disruptive, very powerful, and something we probably did not anticipate coming, and it completely changes the world around us. Well, I see programming languages as black swans as well. And there are several of those languages, in my opinion, that have been black swans over the years. For example, when Ruby was prominent, I would say it was a black swan because it completely shook the way that we would build web applications. And I see languages like Scala and Groovy as black swans, Clojure as a black swan, and off late I look at Kotlin as a black swan as well. For example, Kotlin is one of those languages that compiles to multiple platforms. You can write code in Kotlin, but you can compile down into Java bytecode, you can compile it to JavaScript, you can compile it to WebAssembly, you can compile it to Android devices, you can compile it to native platforms, and so you can pretty much write it and run it in so many different deployments and environments. So that absolutely is a great example of black swans if you think about it. On the same note, though, what I'm really keen to look for is the outliers, because the outliers are the ones that are quietly getting the work done, and all of a sudden they are completely disruptive and they change the way they do things. And of course, those are the real competition. The people who are doing the mainstream stuff over and over and over are not really the threats to your competition, but these are the outliers that can change everything for you because they amass a lot of power and capability in their hands. And from that point of view, I want you to keep an eye and watch out for those outliers. So let's talk about some of the reasons why we want to shake away from the mainstream and look at different ways of doing things. And so don't be blindsided by these disruptive technologies that are coming our way and can change the way we do things. So why can't just one language be enough for what we normally do? And the reason for that is your code is not as general purpose as we normally think it to be. In general purpose programming, we write code for doing general things, but at every single point when you think about it, every single general purpose code is actually doing something really special and something really targeted. And what happens when you use a language that doesn't target to those kinds of behavior is the code becomes really verbose, the code becomes really complex, and the code becomes really hard to maintain as well. And that is something that we need to really think about, and how can we reduce that verbosity in the code to make things much easier. Now, when it comes to these kinds of languages and technologies, how do we reduce the burden of writing the code in these languages? And I want to talk about some of those in here. So for example, what do we typically do in writing code? We deal with collections, obviously, almost all the time. And we have to deal with collections of data constantly when it comes to writing code. And of course, besides dealing with collections, we also deal with file access and dealing with XML documents. We all enjoy creating XML documents, don't we? And then, of course, we also have to think about dealing with various other things. For example, time and again, we have to deal with various kinds of processing. What if we want to start an external process and do data transformations? And what about meta programming ideas? That is something we have to do as well. Now, obviously, a lot of times in code, we also have to deal with concurrency. But concurrency is one of those things that is very intriguing. And we normally get into concurrency because we want to improve performance of code. But unfortunately, if you look at concurrency solutions in languages like Java, what typically happens? Well, you start with a good desire to make the code concurrent, but by the time you get towards the code turns into a monster in front of you, and you start putting the threads and locks, and you're trying to deal with race these conditions, and very quickly you tend to forget what you're trying to really do because the code turns into a monster and becomes really hard to maintain as time goes on. In fact, this is one of my analysis of concurrency in the JDK library, for example. So I'm going to say programming concurrency using Java JDK is like working with a mother-in-law. It's just waiting for you to fail. And this is one of the things that I'm really fearful of the JDK library for concurrency. In fact, when I started programming concurrency, I was finding it extremely hard to really master concurrency. And I used to think that no human being can ever get concurrent code correct. And I was almost to the point of being convinced that no human being can get concurrent code correct. Then I came across one fantastic book by Brian Getz. It's a book called Java Concurrency in Practice. And that is one of the scariest books ever a programmer can read. And when you read that book, you realize that he talks about all the concepts of concurrency and how to actually do it. And after reading that book, I was thoroughly convinced that no human being can ever get concurrency correct. And because it is that much of complexity that's baked into it, and it's impossible. So what you really want to do is to have language abstractions that build on top of that. In fact, I would argue that the JDK concurrency library is the assembly language for concurrent programming. You know, if you ask the question, how many of us program in assembly, not very many of us do. There are a few of us who program in concurrent assembly, so the rest of us don't have to. In exactly the same way, I would argue that the library for programming concurrency should be written at lower level and higher level of abstraction must be provided, so we don't have to deal with it at our code level. But you hear the fact oftentimes when programmers tell you, but wait a minute though, the language I'm using can do that for you. And this is an argument I see repeatedly among programmers. And this is what I really love about programmers. They have this relentless hope that what they use already will solve their problems. But let's give credit where it is deserved. And the first thing to really think about is that, if you think about Java, for example, it is simpler than C++. A lot of times people talk about, oh, Java is simple, but really not. It's really relative. It's simpler than C++ itself. And of course, it gave you the power of write once, run anywhere. But that's being challenged now also because what does the word run anywhere mean? The definition of anywhere was pretty limited when it comes to Java as well. Today we are talking about so many other vast environments, devices and the browsers and different types of machines and IoT devices. And so suddenly the word anywhere is much broader than what anywhere was when the time anywhere was defined in Java. So that is pretty much challenged as well. And of course, the real power is in the virtual machine, the Java virtual machine itself. And one of the things that Java did really well was to master the garbage collector. And of course, the garbage collector has been revised so many times, including the most recent version of Java, and that is evolving quite substantially. And of course, you have the powerful API and class libraries available as well when it comes to the JDK, which is one of the most powerful things. But what happened since 1995 is that there's an explosion in the area of languages. The JVM, of course, got significantly better over time. The class libraries really got stronger and broader and powerful. But what about the language itself? I would argue that the Java language is the weakest link in the ecosystem. Now, to be fair, of course, we can argue that Java has been substantially improving since Java 8, but still this pace of improvement is rather slow for various good reasons, but nevertheless, the language is pretty much a weakest link in that regard. But we deserve better in terms of languages and scope, and there's an explosion of languages on the JVM, and you can look at various different, about 200 languages that are available on the JVM, and all these different languages come with different flavors and different capabilities that you can offer. So this can be really a heaven when it comes to adopting multiple of these different languages. Let's talk about some of these for a minute. These languages can give us flexibility, productivity, it can be expressive, it can be a lot of fun to program in as well. So this comes back to the idea of polyglot programming, as my good friend Neil Ford coined the term, or re-coined the term, as being a polyglot programmer. So we have the power to move around the language landscape and adopt different languages, especially on the JVM, because these languages can compile down to bytecode. We have the ability to really write these code in different languages. In fact, this is one of the exciting things moving forward today, is with the Graal VM being available and WebAssembly being available, we can actually write code in different languages and be able to compile down to the platform, so that gives us a true polyglot nature. And this excites me because the future is actually more polyglot than it's been in the past, and that gives more power to us as the programmers. Well, one of the reasons I'm getting excited really about these ideas of language portfolio is that we can apply different languages for what we do. As Ola Binney wrote about this years ago in this idea of the language pyramid. And he postulated that you could have a very a small and a controlled environment in the bottom, which could be a statically typed, very stable layer of your system. And this could be written using static type languages like Java or Scala or Haskell and whatever that you may think about. And then on top of that, you may have a dynamic layer, which gives you the flexibility at that particular point to be a little bit more malleable in your software layer. And this could be from languages like Groovy or JRuby or dynamic type languages. And then, of course, on the very top of that, you want really a much more flexible layer, which is the DSL or a domain-specific layer. And today, you could write a code in the DSL layer in different languages again. Like, for example, Kotlin, which can give you static typing for DSL as well. Or you can write it in Groovy or Ruby or just about any language, which can give you that flexibility without the ceremony and the burden of the language itself. So there's an absolute desire to really mix and match languages in that regard to build your systems. But it is to your organization's advantage to hire the smartest developers who know to use the smartest tools. And I often hear people say this. I can't tell you how many times I come across organizations where they say, oh yeah, we decided to put a name of a language, Scala, Kotlin, whatever, doesn't matter. But then we backed away from it because we could not really find developers to program in those languages, which is really a shame, because you are saying that you want to use a different language because you could not find the right people to use the sharpest tool, and that really sets you apart. I would rather ask the question, why can't they take smart developers in their organization and train those smart developers to be productive in those languages so that they can actually end up using smartest, sharpest tools, rather than dumbing everybody down and saying, you have to use this common language, which is mainstream because it's easy for us to find average programmers in the market. So something to really think about in terms of how we do the hiring and how we do the project governance. So while the other guys are still getting started, by using the sharpest tools, your programmers can finish the product you are developing and go eat their lunch. And so this is something you can do by being productive in using some of these languages. Well, but how do we get the productivity boost out of these languages and tools? For example, let's think about some of the ways we can do this. Let's say we are interested in using delegation. Now, think about this for a minute. When you read good books on object-oriented design, what do good books on object-oriented design tell you? Well, the good books on object-oriented design tell you you should use delegation a lot more than using inheritance. Well, inheritance is where a class will extend from another class, and you get all the methods and all the implementations of the base class into your derived class. Delegation, on the other hand, is, of course, you are saying that one object will route all its requests to another object based on the particular request. And so as a result, you can't substitute an object when you use delegation, but you can substitute an object during inheritance. Well, the good books on object-oriented design say we should use delegation a lot more than using inheritance. But what do you typically do if you're programming in languages like Java? You say, yep, that's great, thanks for the advice, and you put the book away, you turn to your Java code, and you start using inheritance, isn't it? Why do we start using inheritance like that? Well, the reason for that is, suppose I have a class, let's say, called A, and let's say this class has a method, let's say void f1, and doesn't matter really what this function is doing. And if I have another method, let's say f2, and this method, let's say, is going to return something, again, it really doesn't matter what this method is doing. Let's just return a 0 for now. Now we are told, create a class, let's say, create a class B with F1 and F2, let's say in this case, as in A, and let's say F3. So this is, of course, where you could say class, and you could create this class called B, And clearly in here, you would say public void F3. But the question is, how do you implement F1 and F2? Well, for that purpose, what you could do quietly is you could come in here and simply say extends A and be done with it, isn't it? Now, this was easy. Why? Because you just say extends, and for free, you got F1 and F2. But the consequence of this is, whether you wanted it or not, the class instance of B can be substituted where an instance of A is expected. But that substitutability is a side effect that we did not plan for, and you didn't ask for it. Now, what is the better way? What is a right way to do this? Well, the unfortunate thing is, everyone knows what the syntax for inheritance in Java is. You can either use the keyword extends, or you can use the keyword in implements. But what is the syntax for delegation? And the answer is, well, we don't have one. So the language does not support delegation other than you putting a reference to an object, and you have to do all the manual work yourself. So for example, what you could instead do is, rather than writing that code, you could have said a private A over here, object is equal to new A, and once you create the object, you have to write the code public void F1 and then route this to object.f1 like that. And then of course you would write the next function here, public int F2, and then you would say return object.f2, and you have to take the manual effort of writing every single one of these. Well, the problem with this approach is the code is hard to extend right now, because if the base class changes the definition of the function F1, the signature of it, you got to come back and change in the derived class, in the delegating class as well. That is a manual labor you have to endure. And you have to sit there and route every single call, and that is the expense you have to incur in terms of writing that code. But what if a language were to support an idea of delegation for you so you don't have to do it? Let's entertain this thought for a minute to see how delegation could possibly be used in a language construct. So I'm going to switch over here and write a piece of code in Groovy, and I'll show you a little bit of this in Kotlin as well. So let's write this code in Groovy and see how this is going to work. I'm going to create a class called worker. Now the worker class contains a method, let's call it work, and all I'm going to do simply is print out, let's say, working right here. So my worker is simply has a method called work. Let's make sure this is actually working before we go any further. So we'll say Joe equal to new worker, and we'll say Joe.work, and make sure that code is actually working. So you can see that that code didn't have a problem. But then I create a class called manager. Now, as you would expect, manager does absolutely nothing. And in this case, I'm going to say Bob is equal to new manager, and I'm going to create a new manager object. Now I'm going to say Bob.work. I know this is a very alien concept for a manager. You're asking a manager to actually work. But this manager is absolutely smart, knows that can get away by delegating the work. So this manager says, I'm going to delegate, and it says worker victim is equal to new worker. And as a result, when you run the code, you can see that you don't have to really write much in the manager class. It can perform the delegation for you. Now, the language actually through a library supports this capability where you're able to do the delegation of this so that you don't have to implement the method over and over. So some of the benefits of doing this is, if you were to go back here, if I write another function called analyze over here, and in the analyze function, I'm going to simply say analyzing right here. So this is going to say analyzing, and what if I come back here this time and simply call bob.analyze? Notice that I don't have to really duplicate the code at this point. I can simply call the analyze function. I don't have to touch the manager class, and you can see that it's able to incorporate that method as well. But make no mistake, the delegation is extremely smart. So for example, let's go to the worker and write a method called take vacation. Well, people in this room know what it really means. It usually means for us a code at the beach, isn't it? That's what it really means for us when it comes to taking a vacation. But of course, a manager is not going to be stupid enough to delegate that call. So if you have a take vacation function within the manager, that implementation, of course, over here says, something like all year long, right? So that's going to be doing the work. But if you go back to the Bob and say, take vacation, Bob knows better. So while the work and analyze are delegated, the take vacation is not. So the point really is the delegation can be really smart and can be implemented in a library level. Now, of course, in Java, you could do this also by using Project Lombok, but that comes from an external library, not as easily supported in the language itself. Well, in a similar way, Kotlin also supports the ideas of delegation. So this is an example of Kotlin code, if you will. Now, Kotlin has a keyword called by, and by using the keyword by, you can start delegating to other implementations. But I'll show you a slightly different example of delegation here in terms of how we can implement lazy evaluation in the language using this kind of capability. So for example, let's say I have a compute function, and the compute function in this case, let's say is going to perform some operation. I'm going to just pass an integer, and all I'm going to do is return an integer, but this time I'll simply return, let's say, n times 2. Doesn't really matter, but imagine this is a computation-intensive job. So I'm going to say called over here. But what I want to do is to postpone the evaluation of this function unless I really need the value for that particular function. So in this example, I could say, for instance, if I can say some variable x is greater than, let's say, 10, where I could start defining x to be, let's say, a value of 5. And then I could say, for example, here, and compute, and we'll pass the value of x is greater than 7, I'm going to simply output, let's say, path 1. On the other hand, I'm going to simply output right here, let's call it path 2. So when I run this code, you're going to see that it's going to go through path 2 rather, but it's not evaluating the compute function. But in order for me to, maybe what I want to do is to print out the result of compute one more time. But this would be rather unnecessary because if I were to call with x is 15, you can see the compute was called twice. So to avoid this problem, what I want to do is to store this away into a variable called temp, if you will. And I'm going to simply say in here, temp is equal to, and I'm going to store that away into a variable. Now when I run the code, the good news is that the compute is called only once. But the bad news, though, is what if x is not greater than 10? Well, in this case, when I run the code, you can see that it is actually calling the compute. So we lost one advantage we had a minute ago, which is the compute was not evaluated unless it was really needed. So you can get that feature back by using delegation in Kotlin. So what you can do here is you can say val temp by, and read the word by as delegating to. And you can say by lazy, and then you can just use a level of indirection, and you can just pass that to the lazy evaluation. So when you execute this particular code, what it's going to do is it's not expending the effort of calling the compute method, as you can see in this particular case. But of course, if I were to go back and put a 15, you can see that compute was called, but only exactly once. So it's pretty darn efficient, as you can see. So that is an example of how you can use delegation in the case of language Kotlin. So that is again baked into the language. You can use delegation not only for lazy evaluation, but you can use delegation for performing various other things like validating a property's value and so on, and so or observing a value change for a property and so on. So it's a very powerful concept, very powerful idea, as you can see in this particular case. So that gives you an idea about things you can do when languages begin to support some of these ideas. Well, I want to read a file, let's say. Now, how do you read a file in a language like Java? Now, to do this, you're going to write a lot of different code. One of the things that's going to stand in your way is the low-level API. Now, to be fair enough, this has improved quite a bit in the last few years. With the Java 8 Streams API, you're able to do a better job. And to be honest, in Java 12, you have a few other additional functions as well. But that one thing that's going to still haunt you is checked exceptions. And is checked exception a feature or a flaw? Well, I think most people today agree it's a flaw, but you can't quite easily get rid of it. On the JVM, Java is the only language that supports checked exception. Every other language completely ignores it. So how do we read a file in a language like Java? By writing a lot of code. Now, what is the benefit of this? This is really good if you're a consultant who gets paid by the number of lines of code you write. You can charge more and get rich really writing that code. But if you want to write the code and go home on time, this is a lot of verbosity in your code. Let's take a look at a few examples of reading files in other languages, if you will. So let's talk about Groovy for a minute. So I'm going to write a piece of code that is going to read the current file itself. So right there we have new file, groovy.sample.groovy, which is the file I'm in, and I'm going to call text on it, and that's a code that's reading the file in the code itself. You can pretty easily read the content of a file without much effort, as you can see right in that example. Similarly, here's a piece of Scala code that's going to read itself. So I'm going to say io.source, if you will, and from file, and this is sample.scala, and then I'm going to call a make string right here. And when I run this code, you can see it is going to print out the same content of the file that we are in at the moment. And that's a very easy way to write the code. Again, very low ceremony. You can focus on getting your work done. In a similar way, I could be here in Kotlin, and I could say, for example, java.io.file, and specify sample.kts, which is the file that I'm in, and I'm going to say read text right here, and I can ask it to get the content of the file without much effort at all. So in all these different languages, you can get your work done very quickly, rather than fighting the libraries and fighting the language, and it leads to a greater productivity, as you can see in this particular case. But of course, one of the things to really think about is writing code to write XML. Now, this is something we do from time to time. We have to take a piece of data and generate an XML output from it. Out of curiosity, how many of you have written code that generates XML? Oh yeah, the hands go up. Keep your hand up if you love doing it and you want to do more of it tonight. Yeah, there's only one guy who's there. You and I can have a talk after this talk. But the rest of us, yeah, never mind, we don't want to do it. Why? Because when you first start writing code to write XML, you feel excited about it because it's something new. And then after writing it once, most of us will realize that writing code to generate XML should be given to people in the prison. Nobody in the free world should be doing this, isn't it? And that is really verbose, boring, and we don't want to really do that. Well, let's take a look at how we can actually get that done much more productively, for example. Let's say for a minute I define languages, langs let's say, is equal to, and I'm going to define a bunch of languages right here. Let's start with Java for a minute. And we know that we can provide the author of Java, so we can say Goslin right here. And let's go ahead and say Ruby for a minute. Let's say Mats over here. So that's a good start. Let's see, I want to print the details of languages and authors. How would I do this? I'm going to create a builder right here. I'm going to say groovy.xml.markup builder. And all I did was I say builder.languages. Now, this is one of the beauties of programming languages is where they can give you a power to create very fluent and flexible DSLs or domain-specific languages. Now, I didn't write a whole lot of code, but right now when I execute this, notice how a little XML baby just popped out. That's a very easy way to generate an XML document. But then what you can do at this point is you can go into this one level and say language over here, and you can see a nesting translates to a nested element. Similarly, you can say langs.each, and then at this point you can put the langs inside of that, and that becomes one per language you have in your collection. And then, of course, you can go back a little bit further into this and say key, comma, value, and then you can put that as a lambda expression, and then, of course, our closures, as we call it in Groovy. And at this point, you can see that I have the language I want to print, but at this point, I could simply say the name of the language is going to be the key, because that's, after all, the key of the collection. And you can see that in this case, name equal to Java. But I can go one more level of nesting and say author and put the value inside of that. And as a result, I can produce an XML output very easily, as you can see, without much difficulty at all. So that becomes very easy to create an XML output without much effort at all. And when languages can make things so much easier with a DSL-like syntax, we are not wasting our time fighting the language, and we can be very productive with it as well. Similarly, if I want to create an external process, I remember working on a program where I had to go ahead and call an external process, and the entire code was about 200 lines long. And of the 200 lines of code, about 75 lines was expended just to call an external process and get the result back. Think of the signal to noise ratio in that case. And then I rewrote that code and realized that that code to talk to an external process from 75 lines can come down to mere 3 lines of code or less. For example, I'm going to say git.help right here. And of course, git space help, let's say. Well, that's a string, as we know, no doubt about it. But I can go to that very string, and I can call a method called execute right here, and that immediately gives me a process object on which I can call a text, if you will, and that gives me the output of that process I'm invoking. So you can take commands as a string and turn them into a process object on the operating system and then start interacting with them. And that kind of fluency, sends productivity through the roof, if you will, makes our life a lot easier in terms of how we can write it. Similarly, we can go through and manipulate list and so on. So where does this take us? Well, I'm going to say programmers often suffer excessive primitive obsession. I can't tell you how many times I take 200, 300 lines of code and refactor into 1 or 2 lines of code which are much easier to write, much expressive, declarative, rather than getting dragged down into low-level APIs. So given this, of course, we can benefit from all of that. But unfortunately, though, not everything is green. It can definitely turn into hell as well. So what are some of the impediments we may often run into? The first is you got to contend your enterprise. You often don't live in this world alone. In the development world, you have to really work with other people, and that can be a challenge when it comes to adopting some of these ideas. Secondly, you need to learn something new, and that's a burden we have to carry. Continuously learning something new is something we have to do. And third, it requires discipline. Now, when it comes to contending the enterprise, what are some of the challenges? The first thing is change is really hard. And those of us who are really working really hard to effect change can tell us how hard it is to really bring about change within people's mind and in organization. So one of the reasons why things are really hard is, this goes back to this beautiful principle, the happiness hypothesis by Jonathan Haidt. And Jonathan Haidt talks about this particular hypothesis where a person really carries 2 different things in them. So everybody that you talk to have 2 minds in them. One is the objective and intellectual mind, and the other is the emotional mind we carry with. And what he says is, everybody has 2 parts to them, and their emotional mind is like that elephant, and their objective mind is like the rider. And you can see the proportion, the size right here. The poor rider, he's perched on top of the elephant. And you look at this and say, wow, the rider is in control. Make no mistake, the elephant is in control. It just gives the illusion for the rider at this point. And this all goes really well as long as the elephant agrees to what the rider is saying. But the minute the elephant decides something else, it can bolt off in a different direction, and tough luck for the rider. Well, this is exactly what happens when you talk to people in your organization. You are telling them how wonderful Kotlin really is, how you can be productive, how you can do all of this. And for the first few minutes, you're talking to their intellectual objective mind, and they're like, wow, this is great. If we do this, we'll be more productive. And slowly the elephant says, do you remember me? I'm here. And the emotional mind wakes up and says, are you out of your mind? This is going to require us to learn new things. It's going to slow the project down. We got to get productive with it. And who are we going to hire? And how do we deal with all this new environment? And then the elephant just runs out of the room and the meeting is over. So the point really is, if you want to really convince people, you have to keep in mind that there are these 2 minds you have to work with, not just the objective mind, but also the emotional mind. And if you cannot really cater to that, we're not going to win any conversations. That is something to keep in mind. And so how do we contend with the enterprise? What can we do? Oftentimes people ask me, how do I convince my boss? How do I convince my team? How do I convince my colleague? And the very first question I ask people often is, have you convinced yourself? And if I have not taken the time to convince myself, how in the world can I convince other people? So how do I convince myself? Well, to first convince myself, I need to be able to identify really good reasons why a particular solution, a particular technology, or a language is beneficial to my team and my project. And the conversation cannot be around how cool this is, or look at beautiful syntax. It's got to bring in real value for us to be able to benefit from it. And in fact, if we go to talk to the management and the leaders, it doesn't really help to say it's a cool language. Instead, you want to talk about in terms of money. Hey, here's how much we're going to save in terms of development time. Here's how much we're going to save in terms of bugs that usually get created. And that's a way for us to influence the change. So you have to have a concrete way to convince yourself first before you can convince other people in your organization. And second is to be not infatuated with technology. So one of the things I always ask developers is, tell me 3 things objectively that are in favor, and tell me 3 things that are not good about it. If you cannot speak both and for and against a particular technology, then you are carrying a bias one way or the other. So it's important to really not have the infatuation, but be very well grounded in the realities of what the benefits are and the pros and cons are. And of course, understand and promote the business value. It never helps to convince the use of a technology by saying the technology is cool. What you want to really focus on is to convince people to say, here is how it saves our time, our money. Here is the value we can deliver and how we can deliver faster or more productively. So always focus back on the business gain rather than the fun of the technology itself. And that's a better way to convince the enterprise. And also, in terms of continuous learning can be really hard, but it's much easier if we keep our mental muscles active. And this is one of the things I want to emphasize, is if we learn very less frequently, it's really hard to learn. But if we learn every single day, imagine if I sit in front of a couch and watch TV for 7 hours a day. And you come along and say, hey, Venkat, let's go jogging. I'm going to say jogging. You go jogging. On the way out, give me some more potato chips and go away. Because I'm not going to be able to jog if I spend all day sitting on a couch and eating potato chips. But if I jog every single day, I'm going to be pretty agile. I'm going to be pretty, willing to go for a run. And the reason for that is when my muscles are active, it's easy to flex it. When my muscles are not active, it's really hard to flex it. It's exactly the same with mental muscle as well. If I learn continuously, learning becomes easy. When I learn sporadically, it's really hard. One of the other things to think about is humans don't learn in big chunks. We learn in deltas. And the key is to really start building these deltas in our mind so that it becomes easier to learn these things every single day rather than trying to learn a lot of things in a short amount of time. And this brings back memories to one example. I was in a company teaching a course, and in front of me there were 2 people, 2 gentlemen. They're the same age. They went to school together, and they've been working for about 30 years or so in the field. But the difference was, one that was on my right side had programmed in about 10 different languages. The one on my left side, his colleague, even though had the same education, same background, has spent the last 20 years programming in only one language. What was exciting for me in this particular course was I would introduce a concept, and the minute I introduce a concept, I would get 2 completely separate reactions from the 2 people in front of me. The person on the right would say, oh, wait a minute, that's so intriguing. Can you compare this to OCaml? And can you compare this to? And he was like on fire, wanting to be comparing to all the other things he knew. And the other person was like, oh my God, why are you doing this to me? I was so happy programming in the language I was programming in. This looks so alien, and I got to learn one more thing. And that's when I tweeted this particular observation. The time you need to learn a new language is inversely proportional to the number of languages you've learned in the past 10 years. So if you have learned many different languages, you're going to need very small time to learn a new language. But if all you have learned is one language in the past 10 years, it's going to take a lot more time and effort to learn a different language moving forward. And of course, this brings back to Paul Graham's observation of what he calls as a blub paradox. So he says that our corporate world has what are called blub programmers. So who is a blub programmer? A blub programmer is a programmer who goes to work every day and programs in one language, and he would look at, or she would look at, the language which is less powerful and say, well, gosh, why would I use that language? Because the one I'm using is so much more powerful, I don't want to really consider that other language. On the other hand, may look at a language which is more powerful and may say, it looks really weird. My language is much easier to program in. I don't want that. And so they end up actually programming in the language they program, which is the hypothetical language called the blub language. So a lot of us are blub programmers in the corporate world, unless we are just willing to break away from that cycle and start really looking at other languages. And so that is something we need to really think about, not becoming a blub programmer. Well, Paul Graham makes a statement, in business as in war, surprise is worth as much as force. And that is one of the things I'm really excited about learning different technologies and different languages, is to be able to come up with that surprise, to be able to solve problems more effectively than a conventional mainstream solution would provide. But of course, using these languages require one important thing, which sometimes is lacking in the world, which is a greater discipline. Now, these languages provide flexibility. They provide meta-programming. They provide relaxed compilers. There are so many benefits they provide. But programming without automated testing can become a roadkill. So we need to really come up with these ideas to use, but we also need to really invest in getting a fast feedback loop, and that absolutely is very critical. If unit testing is so important, you may ask, why is it not really popular? Why is not everybody doing it? And I'm going to say it's very easy to answer this question if we compare it to something else. Unit testing, I'm going to say, is the equivalent of exercising. Now, if you look at the population of the world and ask how many people believe exercising will lead to a good health, almost everybody would agree that exercising is good for health. But if you ask the question, how many people actually exercise, I'm sure a lot of people will have good excuses to give. Oh, I don't exercise because, and then we'll fill in the blank because of that. So this is intriguing because everybody can agree that exercising is good, but it's not for them because they got other important, better things to do. In a similar way, automated testing is important, but it's for others to do because I got more important things to do on my project. I can invest my time and money and effort into it. So in that regard, if your company wants to really follow the standard and the mainstream practices, what they are telling you is that they want to move towards a pathway towards mediocrity, and I think we can do a lot better than that. So what do we do to make this effect? Well, beautiful quote by Carolyn Schroeder. It says, some people change when they see the light, others when they feel the heat. So until we actually feel the heat, maybe we won't affect the change, and we really need to be able to have seen that heat so we can actually go start doing things in that regard. So we need the discipline in our organizations to be effective. If we don't have the discipline, unfortunately, we jump into a technology and we burn our fingers with it, and then we blame the technology and say, gosh, we don't want to use it, and we fall back. So having a good discipline, automated testing is one of them, but there are other disciplines we need to bring in. And remember the wise words of Uncle Ben. He said, with great power comes greater responsibility. And so it is for us to really have the discipline in bringing in these technologies that is absolutely important as well. So to summarize what we talked about, it can be heaven or it can be hell. Well, it's definitely heaven for me when I can be productive, when I can leverage all these technologies, when I can really improve and adapt these technologies and make them better. But it can also be hell if I don't have the discipline, if I can't convince my organization properly because I haven't taken the time to convince myself, and if I can't invest in quick learning, or the team doesn't have the ability to continuously learn, it can definitely turn into a hell as well. And that is something that needs to be thought about. But of course, with a proper motivation and skill and desire, I absolutely know that we can choose wisely. And of course, if we do, your efforts will pay. Hope that was useful. Thank you.